Hello everyone, my name is Vaibhav Singh and I will be walking you through my project which is plagiarism checker. I have built using Python. So this project leverages cosine similarity calculations and query processing to check content similarity with online sources. So it is an excellent tool for ensuring originality in writing, which is crucial in academic, professional and creative contexts. Okay, so let me show you first of all that how my project works. So what I will be doing is, let me copy a text from web. Yeah, so okay, okay. Since I have copied this text from GFC, I am expecting that this text is will show 100% plagiarized since it is copied from internet. So let's see what's the output. Yeah, so you can see it is showing it is 100% plagiarized, and it is also showing the link of the website from which it is plagiarized. You can see this is the same link. Okay. So the main objective of my project is to analyze a given text and compare it with the content available on the internet to find matching percentages and the related links from which it is copied. It is designed to help I, it is designed to help identify potentially plagiarized content and provide users with links to that similar resources. So the project I have built, yeah, as you can see that so the project I have built is using Python, and I have utilized several libraries and frameworks. I have used Django in my backend. I have also used natural language toolkit, which I will show you, and I have used Google Custom Search Engine API, which is the major part of my project, and cosine similarity algorithm to calculate similarity score between two texts. So why I have used Python? Because Python was chosen for its simplicity and readability and availability of the libraries, which are well suited for this particular task, and like text processing and web scraping. So let me show you how my project works actually. So let me explain you how my project works. So whenever I put some text or put a document, and you can see I have also used file uploading method. So you can also upload a file. Yeah. So as you can see that you can either put a text or you can also use the file upload method. You can upload a docs file and you can search, and it will show you the same.
Yeah, let me explain you the workflow of my project. So the process begins with the user providing a block of text or uploading a file that they want to analyze. And this text can be an essay, an article, or any written document. The input text is too large to search for the web directly. The first step is dividing it into smaller manageable pieces called queries. And I have made get queries function for this. So yeah, so this is the get queries function, and the function splits the text into sentences using punctuation like periods, question marks, or exclamation marks as delimiters, and stop words such as is, the, of are removed using the natural language toolkit library to focus on meaningful words. If a sentence is too long, it's further divided it into several overlapping chunks of a fixed size. I have set the size up to 9 here, as you can see, ensuring no information is lost. And this also makes the web searches more specific. Then each query is then sent to the web search module, which interacts with the Google Custom Search API for every query. And so the Google Custom Search API will return a JSON, and this API will retrieve the top 5 most relevant search results. Uh, it will return URL as well as the snippet of that top 5 search result. The text snippet from these results are compared with the query using a similarity algorithm. So then I have written the cosine similarity algorithm. To determine how similar the queries is to the search result, we use the cosine similarity algorithm. And every text is so what happens in cosine similarity algorithm is every text is treated as a vector of word frequencies. The cosine similarity measures the angle between these vectors. Uh, a smaller angle means a higher similarity, producing score between 0 and 1. So let me demonstrate you with an example. So let me demonstrate this video. So let me demonstrate you again with an example. So let's take this as an example again, and I will explain step by step. Yeah. So whenever I am inserting this sample text, the get queries function. So this is the get queries function, and this get queries function splits it into small chunks and removing stop words and creating meaningful queries. For instance, one query might look like this. Yeah. Okay. So in the very first query, these 9 words will go. Then these queries are sent to the web search function, which communicates with Google's custom search API, and you will see the 5 results for a query being fetched. Snippets.
Let's start with the workflow. The user provides a piece of text they want to check for plagiarism. This text is taken as input and passed into the system for processing. So then the text is then broken down into manageable chunks or queries. Let me show you. Yeah. So as you can see that I have set the limit is limit up to 9. So only 9 words will search one by one. You, so you can see that, I'm using this get queries function. So this step ensures that we can efficiently search for matching content online. So let me explain you how it works. So this function first splits the text into sentences using regular expressions to identify punctuation marks like periods, question marks, and exclamation points. Stop words like the, is, and in are removed to focus on meaningful keywords. Longer sentences are further divided into overlapping subqueries of a fixed size, ensuring coverage without the overwhelming the search API. So next, what happens is the queries are sent to the web search module. Yeah, as you can see that this is the web search module where the Google custom search API is used to retrieve relevant search results for each query. And the top 5 search results are considered here. And since it is easy to brute force, I will tell you how I am doing this. So the content snippet of each result is analyzed using the cosine similarity algorithm, comparing the query text with the retrieved snippet. The result with the highest similarity score is identified and the link is stored. If the same link appears in multiple queries, we average the similarity score for more accurate result. Okay, so let me explain you how this cosine similarity algorithm is actually working. Yeah. So as you can see that what I am so first I am converting the text which I am getting. So so the text I am getting into lowercase. Then I am passing this into a function text vector, as you can see. So this will convert uh, the text into vector. Since the cosine similarity algorithm works on vectors, so what cosine similarity algorithm actually does, I will tell you that it converts the cosine angle between the two vectors to analyze how much similarity is between them. So as we know that cos theta equal to a dot b upon mod a mod b if there are two vectors a and b inclined within an angle theta. So after converting them, so here I am getting two vectors. So here what I mean by vectors is it is a it is a hash map of string comma integer, which will store how much time in each text a word appears, how much time a word appears in that particular text. So like Ram is going to market, so Ram has frequency 1, each has frequency 1, going has frequency 1, 2 has frequency 1, market has frequency 1. So this type of vector, I'm passing both of this vector into that get cosine function. So this get cosine function is doing brute force. So what it is doing that the actual content, so the actual content which I have put, which I have searched, it is going one by one through iterating through all the keys of that hash map and searching whether that particular key also exists in the snippet which I have got. And if that exists, it is multiplying it, since to calculate the dot product between them. So first of all, I'm calculating the numerator by this formula. Then I'm also calculating the denominator, which is see that square root of sum 1 into square root of sum 2, which means the magnitude of both the vectors. And I am returning the numerator by denominator, which is the angle between them actually. So, so this cosine similarity algorithm is processed for all of these to calculate which has higher cosine similarity. By that, it ensures that so the final result is a score between 0 and 1, where 1 indicates perfect similarity.
So if I talk about the advantages of my project, so this project has several advantages. First of all, that efficiency by breaking text into smaller queries is it processes large inputs without overwhelming the system. Second is the accuracy. That's a cosine similarity algorithm ensures precise matching even with the partial matches. And third can be scalability. That the modular design allows for future integration with machine learning models for deeper analysis. And the challenges which I have faced in this project, uh, there are some challenges. First of all, that API limit is a challenge. Google Custom Search Engine API imposes a limit on the number of requests, requiring careful management. Second is the query optimization. Splitting text into meaningful queries without losing context was tricky one. And third can be error handling. Ensuring the program handles missing API responses or poorly formatted text gracefully was another hurdle for me.
Hello everyone.